after this to work on a few of those problems too. Okay, so when we think about traditional kind of recursive functions and loops that we've done so far to today, right? They've kind of followed a very similar pattern, which is, hey, like let's start somewhere, let's work our way down, and let's try to return the values, right? One thing that I noticed several groups doing is they wanted to create, almost a global variable, right? Say like, hey, let's keep a counter or a sum or something that keeps track of things. But one of the harder things there to do is in a recursive function, the goal is not to keep a counter and pass that counter, to the next person, to the next iteration over and over again, because at that point you're just trying to basically cobble together a iteration function, right? That happens to use like one small bit of recursion. The point of recursion is each problem only solves like what it's supposed to solve, and it gives its results back to whoever called it, right? And the idea is whoever calls it, the person is a function that's going to take the trouble to actually assemble all the answers together. So when you think about the sum digits problem, for example, right? It's like we're not having a global variable called sum that keeps track of all the total numbers that we've seen so far. All we're saying is, hey, I'm going to give you back what my total is plus whatever the sum function of the number one less than me is, right? So at no point do we ever kind of keep track of other people's sums. We just say, here's my sum plus the sum of the guy coming after me, right? And the guy after me say, here's my sum plus the sum of the guy coming after me. Eventually, so on and so forth until we reach our base case in which we say, here's a number, right? Here's a sum, and we just go and run with that. So, so really, like one of the places where recursion really starts to shine is when we're dealing with uncertain data. So far when we deal with arrays or strings, it's like, well, I know how long the array is, so I can iterate through it. I know how long the string's going to be, so I can iterate through it. I know how many numbers exist between num and 1, so I can go through it. But what if we don't know, how many of something there is, right? So here's where it comes down to something like nested data structures. One of the earlier workshops, I think it was on arrays. We did. Someone asked me, it's like, well, like we assume that if everything in an array is a number, I can process it, right? If everything in an array is either a number or an array, I can process it. But what if everything in the array? What if something in the array is an array, and then something in that array is also an array, right? And really, like that logic can extend infinitely because we can have infinite levels of nesting for data types. When we look at something like that, right? Like that's totally valid JavaScript. It's a superly heavily nested array, but it's valid. But in order for us to get to that number 9 there, like if we use our traditional like for loops, like that's a lot of manual for loops we have to write, right? And even when we write 9 for loops, there's nothing that tells us, hey, what if someone puts another array inside that 9, right? And now we have to add another for loop. It becomes very apparent, like very quickly, that writing an iterative function is it's not scalable, right? We don't know when to stop writing it. Luckily, that's the whole point of recursion, right? Recursion says, I will keep going until I solve this problem. Very similar to a while loop in that way. So this is probably the most common set of problems that we're going to talk about, in which it's like, hey, recursion is going to be the only way for us to solve this problem, whereas trying to use an iterative approach just wouldn't work. So let's actually solve the problem that I just listed out, right? Which is very simply, hey, if I have an array and it's infinitely nested, how do I actually get to every single element in every single inner array too? This right here is our standard printout an array, right? We go through an array, we have a for loop, we create the element, or rather we get a hold of the element and we log it out. Very straightforward, nothing special, nothing fancy. And at some point, we also did a problem that basically asked, okay, what if instead of having everything be a number, what if everything was either a number or an array? Right? And we did something very similar to that, if you remember correctly, right? We had a for loop, we go through, and we basically have a if-else statement, right? If the element is a number, or rather, if the element is an array, we then wrote a for loop there to iterate through it, right? If it wasn't an array, we would just console log it out. But notice how this time, rather than trying to write the for loop again, Remember how like last time it was like, oh, 4i equals 0, let's do this. And then for the inner array, it's like, okay, 4j equals 0. And like once you start writing the same code over and over and over again, you'll probably start thinking, hey, like why don't I just reuse the code I've already written, right? Like that's one of the core tenets of programming is that we should be trying to reuse our code as much as possible. We shouldn't be typing the same thing over and over again. Logs in an array, right? If we look at this function, what is it doing at the end of the day? Well, there's only one thing in this logs in array function, right? It takes an array, it iterates through that array. Let's skip this part for now, but assuming if every element in it is not an array, all we're doing is console logging out the element, right? And really, like that's what we want this function to be doing, right? We want to have a function that solves a very, very small micro problem. In this case, the micro problem is if you give me an array, I will print out for you everything in that array, as long as it's not another array, right? So if we add this part to the, if we add this if statement that says, hey, if this element is an array, well, ideally it'd be really great to have a function that takes in an array so it could print out everything for us, which is exactly what we've already written here, right? And so now, if you see on line 6 there, what we're doing is we're actually calling the logs in array function again within it. And we know this is valid because, once again, we've already confirmed that element is indeed an array. If this array that is array is going to give us true if we pass in something that is an array. And then we're saying, great, I have a function I've written whose job is to log an array. Here's an array. Go knock yourself out, right? And so if we think back to our previous example of having like 9 nested arrays here, right? Well, initially, if the initial array was 9 nested arrays, right? We go through here, well, we've gotten rid of 1 nesting, right? But when we get here, it will say, great, let's start another iteration of logs in array, or another instance of logs in array, and let's pass in an array that has 8 levels of nesting now. Well, that 8 levels of nesting array is going to go through this, and it's going to come and encounter the same exact problem, which is, oh, is one of my things an array? It is. Great. Let's call another instance of this logs in array function, and we'll now handle an array with only 7 levels of nesting. And in fact, that will keep going on and on nonstop until, what's our base case in this instance? Our base case is we essentially reach an array in which nothing in it is an array anymore. And all we're doing is going through it and console logging out every element, right? So in this case, the base case is not nearly as obvious because we don't really have an instance where it's like, oh, like if equals this, return, right? Or if this, like stop. But really, like that is the base case, right? The other way to think about the base case is, under what circumstances do we not call another instance or another iteration of this function, right? At what point do we stop recursively calling this function? And so when I look at logs in array, is we are recursively calling this function every time we encounter something that's an array. So therefore, the base case is, wow, eventually, hopefully, I get to a state in which something is not an array, right? So if I was to pass in an array with no nesting, it would go through once, it would go through the for loop. This would never be true, and I would just print everything out, and my function runs once, and it does its job. If I had 1 level of nesting in the array, it would go through. It would, for each individual element, it would say, "What are you? Are you a array or not?" If the first element is an array, or the second element is an array, it will call another instance of this logs in array function, right? So even though in this case we don't know when it's going to stop, it's also reasonable for us to know that, yeah, eventually it's going to stop, right? We're going to reach a scenario in which there's no more nesting, or there's a finite amount of nesting someone can do in an array. We're going to reach the end of it, and then we're going to be finished. Okay, so this is an example of a case where, yes, there is a base case. Yes, we are approaching the end, even though we don't really know when the end will definitively be, right? And so, okay, so I'll pause really quickly, but does this make sense? Because this is pretty much like the entire lesson. Like, we'll go through a few more examples of this, but like this fundamentally is the point of recursion and its ability to solve problems that iteration wouldn't be able to solve. Cheyenne?
Can you just say exactly what it is again that's making it go, that's going to stop it?
Yeah. So let me open up a REPL really quick. Okay, so, oh. Okay, so when I run this logs and array function, right, at every single point, let me console log out my current element. So I'll say console.log out current element, and then I'll put in element. Okay. So what's going to stop this function from, or rather, oh, how about this? I'll do a console log, and I'll console log something. I'll say new call of logs and array. Okay, that's going to tell us every time we start a new instance of this function, right? The first thing it does is it'll console log and tell us that a new instance of this function has been started. And let's change this for now so that we just have an array with all numbers. Okay. In this case, when I look at this, right, when I run this logs and array function for just this logs and array function, notice how this function only runs once, right? Because when we go through it, I new call of logs and array. Yep, I go through this array that I gave you. It has 3 elements, 1, 2, 3. As I go through it, at every single juncture, the question becomes, is the element an array or not? We looked at it, and in every instance, the element is not an array. It's all numbers. Sorry, let me share this with the group so people can follow along with the computers too if they want. Okay. Okay. So at this point, like, this is never true, right? So we never call logs and array again. If I ever call logs and array again, I would see it print out over here, right? So all I do is I go through this array once. This never happens. So all we do is console log out element, console log out element, and console log out element. And so in this case, for a plain array, we call the function once, we log out 3 elements, and we're done. Okay. On the other hand, if there was a level of nesting in this array, now what we see is, okay, great. I'm passing you an array with 2 elements now. The first element is a number, the second element is another array, right? So, yep, I start off with my initial call, makes sense. I then go through every element in the array. The first element is what? It's a number, it's a 1. So I go here to my else, I print out. The second element, what is it? Oh, it's an array. What do I do if it's an array? Well, I'm going to take this array, I'm going to pass it into this logs and array function again. As in, I'm going to call this function again. I'm going to call another instance of it. And indeed, after this line, we see this new call of logs and array running, right? So now we've started another instance of this array. And in this case, in this new logs and array, actually, let me just, okay, right? So what I did was I basically print out, whenever we start a new instance of logs and array, take a look at the array that's being fed into us, right? So the initial array, the initial call, what's being fed in is literally what I called with it down there. I saw 1, I printed out. My second element is an array with 2, 3. So in order to handle that, I call logs and array again. And this time, the array I feed it is my second element. It's an array with 2 numbers, 2, 3. And as I go through this array, I see the 2 I printed out. I see the 3 I printed out. After I'm done with this for loop, I've reached the end of my function. So my function's done, right? And then that means this inner logs, this call of new logs and array is now complete. And in fact, I can prove that too by just adding a console log here that says logs and array is done. Logs and array is done. Okay, so we called the original function with the original array. We see the 1 we printed out. The second element we see is an array of 2, 3. So we call another instance of logs and array with the array 2, 3. We print out the 2. We print out the 3. We're now done with this inner call of logs and array. That's why this says logs and array is done. And then when we go back to our outermost, our first initial call of logs and array, we see, oh, okay, we've done the second element. There are no more elements. This function is also done. And at that point, we're done with this entire problem.
So that's why I say it twice.
Right. And in fact, if I also, I should have left it in here then. If I do something like this, this will tell you kind of, like, actually let's even get rid of this. This will tell you is initially we call logs in array with this outer array. We saw the 1, we print it out. Then we encounter this 2, this array of 2, 3, right? We call that array. We call logs in array again with that as the input. We print out the 2. We print out the 3. Logs in array is done for processing this array of 2, 3. So that function finishes, and then when we come outside, logs in array is also done now for processing this outer array initially, right? So if you think of our call stack as we add this to the call stack, then we add this on top of it to the call stack. This finishes, so we wipe this off, and then this finishes, so we wipe that off. And in fact, when I go back to the slides, I think there is like an animation there for how the call stack's gonna look here. 1 second. Okay. So our call stack initially starts with that inner element, the 1, 2, 3. We log out the 1, then we logs an array with just the inner element of 2, 3. We print out the 2, print out the 3. We've now finished with the inner element, and now we finish with the outer array as well. And at that point, we're done with the entire problem. Does that make sense to, I guess, anyone, to everyone? Hopefully, Tyler.
Just to just clear my mind, could you add just one more time like another array, and it should realistically cycle through again?
Yep. Oh, you want to do it?
Yeah. Can we just see
Sure.
I think in my head I think that works, but I want to see if we were to add a bunch of arrays, what would happen?
Sure.
No problem. There was 12 or 9 arrays or whatever.
Yep. So let's add this now. Except this time we'll actually do something like we'll add some names. We'll add Eric and then Tyler, and then here we'll also add another name in another array inside of here, right? And we'll call this like John. Cool. So this is my array now. It's pretty nasty. It has numbers and strings. It also has nested arrays within nested arrays. When I run it, this will be kind of painful to talk through, right? But and hopefully you can pull it up on your own computer if you really want to see the nitty gritty of it. But essentially we have this outer thing. So we go through every single element, right? The first element is a 1. We resolve that here. The next element is a 2, 3. So we start a new iteration of logs and array to handle the second element of the array 2, 3. We handle it. We finish up, and so now this function is now done. We then said, okay, great. What's next? What's next is another array with a bunch of names in it. Okay, Eric, Tyler, and an array of John. So we handle Eric. We handle Tyler. We see John is in its own array. So then we start another instance of logs and array to handle just John. Once we handle that, we close off the John loop. We close off the Eric, Tyler, John loop, and then we reach the end of that array. So now we've done the entire problem.
Then on top of that, we don't return anything here, and obviously,
yep,
we want to be returning things. Does that mean if we could just get rid of console log next in line 9 or line 8? I'm sorry, 11 now. Moving. Can we just have return element? Would that still work, or how would this?
We will return it, but
would that end it? I'm just not exactly sure how. Returning things.
What return does is return basically says, okay, whoever asked for this, here you go. The only question is, let's say I return Eric's name here, right?
Yeah.
This will become Eric, but we never do anything with it, right? There's no return Eric here. It's just there. So basically, as soon as we get it, it disappears. So if we do a return element here, nothing's gonna print out except for the very last thing that we process. So this console, or actually. Hold up. Where does our console block? Sorry. Okay, it prints out the 1. But essentially, the point here is that if we remove this console, or if we do this return statement, it also kind of breaks a function, right? Because the point here is we want to iterate through this entire loop.
Yeah.
So if I have a list of 3 numbers, or 3 things like I do here. As soon as it hits the first thing that's not an array, it's going to return it, and then there's nothing else to do. So the function's going to end here at this point.
In a scenario, would you be how would this in a real-world example be helpful? we're not actually getting anything out of it. We're just like const log. You push these elements to a different array. Like how would that
How could
necessarily?
you capture the results? Like one of the examples was the result was captured. The result was set into the function calling itself.
Right. So we have two more other like practice problems that will show how to capture the return values, but like for now, I think we're more like just getting through it in the first place.
Sure.
Does anybody have any questions on like how this function works? Everyone knows how it works. All right, cool.
So we'll find out.
I love the optimism.
You'll share it though.
You guys have the slides. Okay, cool. Okay, so now let's take a look at another problem here, right? What this problem does is, and here's where we start dealing with returns, right? The idea is, hey, if I give you an array, can you just, or rather, if I give you an array of strings or nested arrays of strings, can you join all the strings for me together into one like massive super long string, right? So in this case, like the return does matter, right? So if I just said, here's an array of strings, can you like join it into a super long string for me? Well, this is our normal default. This is our normal default for loop, right? Nothing special, nothing fancy. All we do is we create essentially a global variable called final string. We keep adding elements into it as we go through the array. But what if rather than having everything be a string, everything could either be a string or an array containing other strings? Well, now we kind of see this. Now we see kind of where the return comes into play, right? The way this function is set up is we still have this final string variable that we're basically creating from scratch, and then we end up returning, right? The question now is, what do we do to the final string in the middle of this? We have a for loop here that iterates through, I guess, the array of elements, right? And once again, we're doing a very similar process, which is, hey, for each element, if the element is an array, let's do one thing. If it's not an array, let's just do what we did before, right? Which is just plus or equals the element to the final string. And at the end of it, we return the final string. Okay. However, if the element is an array, we are still plus equaling it to the final string. But what are we plus equaling? Well, we're plus equaling a function, hopefully something that can handle an array of strings, which that's what this entire thing is, right? Our entire function concat else is meant to handle an array of either strings or array of strings plus other arrays. So an almost identical logic to the previous problem, right? We're still checking each element, and if it's an array, we throw it into this concat else function that then is designed to take an array, iterate through the array. And in fact, for this inner array, if everything is a string, we'll skip over this if clause entirely. We'll never hit it, and all we keep doing is editing the final string, and then we return, right? The important thing here to note is that when we return this final string, we are editing the parent version of the final string with it, right? This final string is plus or equaling whatever this return. So this is returning like an inner string. Like in this case, the outer string will say, hey, great, let's process the A first. Great, my final string is now A. Let's process this like inner array now as well. If the inner array returns a string called BC, this will say final string, which is just A, plus add BC to the end of you. And so now we actually have a way to capture the result as we go along. This is very similar to the sum nums problem you guys did this morning, right? Where it's like we return num plus sum nums of n minus 1. This is the same exact thing, except now we're not always guaranteed to add a recursive call. We very well could just say, great, give me back a normal string, right? And we never touch the recursive part of it. So when we run this function out, we have our call stack. Initially, the call stack goes for the outer array of A, comma B, or A, comma array B and C, and our final string is just nothing. It's an empty string like we defined on line 2 there, right? As we go through it, we're like, oh, the first element is an A. Cool. no recursion, nothing fancy, just our for loop. So now final string is equal to 8. Let's go to the next element. The next element says, oh, why don't we add a concat else, or because the next element is an array, why don't we add concat else this B and C array to you? Well, okay, that's cool, but I need to figure out now what concat else of B comma C is. So now we add this concat else B comma C to our call stack, and this second concat else is going to have its own version of final string, right? And when it starts off, the final string is what? It's just a blank string, because when this function runs for the first time, it's going to define final string as an empty string. It's going to say, okay, great, let's go through this array now. The first thing's a B, I'll add it. I'm now a B. Now the next thing's a C, so I'm going to add a C. So now I'm a BC string, and voila, I've reached the end of my inner array. There's nothing else to run, or rather, there's nothing else to run in my for loop. So I'm done now, and now I can go to line 11, which is return my final string. What's final string? Final string of the return value for this is BC, right? And so almost like exactly like in our sumnums problems here, in our sumnum problem this morning now, concat else array B comma C is equal to BC, right? So we just take this value and we replace it to whoever was looking for it, right? Whoever was looking for it, say, hey, I had this A string hanging out. I need to add it to concat else B comma C. Well, great. It's just BC now. Do. And so when I add it up, I get A, B, C. And I've also finished this outer array too, right? The A is finished. This BC array is now finished. I'm done processing this inner array. So my for loop for this concat else function is also done. And now I've reached the end of the line. All I got to do now is return ABC. And that's it. Right? So it's not that different. It's just a matter of kind of what you're doing and what you're looking for. And I guess like the other thing here to notice is that like using recursion is totally fine, right? In this case, we're still using a for loop, right? But like the for loop is used to solve kind of like the mini problem, if you will, like the pure like the essence of the problem, right? We're not using a for loop to iterate through the entire array all at once. We're using it to iterate each element, and depending on the characteristics of the element, we say either do this or do this, right? Like we're not using a for loop to solve, all the internal nestings. We're using the for loop to solve only one level of nesting, and the understanding is if there's more nesting, the next for loop is going to solve it, or the next iteration of this recursive calls for loop is going to solve it, and if there's more, the following iteration is going to solve that too, right? So we don't worry about anything except for kind of the current problem at hand. In this case, it would be the current level of nesting. And then lastly, we can also very easily do this with objects too, right? Arrays are, something that's typical for us to, arrays is something that's typical for us to iterate through. But if I have something like that's an object, well, that's totally fine too, right? If I use a for in loop for objects, like that's just a glorified for loop, right? That just takes me through every single key in the object. And so in this case, if I have something like that on line 12 there, which is an object with a bunch of keys, every key has to be a string, but every value in this case is a number, right? If I want to add up all the numbers and the values, well, that code between lines 3 through 10 is something that works perfectly well, assuming there's no nesting, right? We start with sum equals 0. We iterate through every single key in the object. For every single key, we just add the value of that key to the sum, and by the end of it, we return sum, right? This is no recursion, just a straight plain for in loop. However, if something inside, or rather if the values inside were nested objects, our code looks, in some ways like almost it mirrors our previous problem, right? Which is we still have our kind of for loop there on line 3, except instead of a traditional for loop, we have a for in loop. We still look at every value of every key, except now we just check. If the value is an object, well, we just add the sum plus or equal to whatever the object's going to give us when we pass it into another iteration of sum vals, right? No matter what sum vals it gives us, we know it will always be a number, right? Because when we look at the code, on line 2, we instantiate sum equals 0, and on line 11, we return sum. And we kind of assume, just for practicality purposes, that at no point in between do we change the type of sum. So we're basically just changing a number, right? It starts at 0, it goes somewhere else. So even if nothing happens to it, we know that we'll always return at least 0. And then on line 8 here, right? If all the values in the object are numbers, we'll just add the number to the sum. On the other hand, if the value is an object, well, let's just use sumVals. We'll give it an object, have it calculate the sum for us, and then we'll add that sum to our current sum. Right? So this is almost a mirror image of the last problem too. Like these problems are very formulaic in that way. So now, no matter how many levels of nesting we have here, it doesn't matter, because at each level, we're going to say if we need to make another call, another kind of object parser, we'll just do it, right? If we need to call sumVals again, we'll just do it over and over and over again until we get to a point in which all the values are no longer objects, or rather, no values are objects anymore, because we've kind of dug deep enough to process all of them. So if we go to our call stack now, I mean, this one's going to get really hairy, right? Initially, we calculate sum for A, then we look at B, and B is this massive object, or the value for B is massive object. So we look at the sum for that massive object, which is C, and then the value for C, the massive object. So we look at it for D, and it's like this one, you can look at the slides on your own. Like, it just kind of gets very complicated very quickly. But the point is, once we get deep enough, we reach two values that are just numbers, right? 2 and 3. Great. Well, in that case, there's no more recursion call anymore because we never encountered another object. 2 plus 3 is 5, and now we just work our way backwards again. 0 plus 5 is 5, and then we eventually get to whatever the answer is here. Oh man, it's really slow. Okay, that is pretty much it. So that's like a class of problems that, once again, we can solve with iteration, we can solve with recursion. Yeah. Any questions?
I think everyone has a lot of questions.
Okay, cool. Yeah, so I mean, the good news is you probably won't come across any questions this hard on the assessment. Not saying you definitely won't, but you likely won't, because I think for the assessment, right? I think normally what they'll, I don't know. I mean, I'll say it, whatever, it doesn't matter. For the